Today we are going to understand integration, right? How to do integration by substitution, correct? Now one of the questions that I am going to take over here is tan to the power of 4 root x multiplied by sec square root x divided by root x. If you look at over here in this question, how do you identify that you are supposed to do it integration by substitution? Because it's very clear, it's given in the form of a into b divided by c, right? So you need to definitely take substitution into consideration. So when I take substitution into consideration, my first step would be, I would take let root x be equals to t. So when I am taking root x equals to t, I will be finding out the derivative of root x equals to t with respect to t. So I will differentiate both these with respect to t. Okay, so differentiating with respect to t, I get d by dt of root x is equal to d by dt of t. Understanding it? Right? So what will be the answer? D by dt of root x. So d by dt of root x is going to be 1 by 2 root x dx is equal to dx is equal to dt. Correct? So therefore you get 1 by 2 root x into dx is equal to dt. So therefore your dx will be equal to 2 root x dt. So I have shifted this dt on the other side. So that therefore it became 1 by 2 root x dx is equal to dt. Clear? Okay. So now again when we look over here, I have got dx is equal to 2 root x dt. I have already taken root x as t. So in place of root x, I can substitute the value t again over here. So this can be also written as 2t dt. So I get dx is equal to 2t dt. So this is my first substitution, that is root x is equal to t. My second substitution is dx is equal to 2t dt. Correct? Now both these values I am going to substitute in my integration. What am I supposed to find? Integration of tan to the power of 4 root x into sec square root x divided by root x. Definitely I am integrating it with respect to dx. Correct? Now tan to the power of 4 root x, since root x is equal to t, in all the three cases this integration term will change to integration of tan to the power of 4t into sec square t over t, because my root x is equal to t, into what is the value for dx? From my second equation, I can very clearly see dx is equal to 2t dt. So this is 2t dt. Are you clear over here? Now when you look at the equation, you can cancel this t, and 2 is the constant term which you can take out of the integrand. So you get 2 integration of tan to the power of 4t into sec square t dt. Again the complex, because now once again we have landed up in getting the value of tan to the power of 4t into sec square t dt. This is again a into b format, and you don't know the integration of tan to the power of 4t. You have the integration of tan x sec x, correct, dx, but not of tan to the power or sec to the power integration. So we are again going to do over here a second substitution, a dual substitution we can say. So what am I going to take over here now? I'll be taking let tan t be equals to u. And another term I am taking up. Here I have taken root x is equal to t. I am now going to consider tan t equals to u. So when I am taking tan t is equal to u, once again I am going to differentiate with respect to u. Correct? So when I differentiate it with respect to u, I get d by du of tan t is equal to d by du of u. This gives me sec square. What is the differentiation of tan t? That is sec square t, and this is by your du, because d by du of u is 1. This du you shift it on the other side, so you get sec square t dt is equal to du. So we get sec square t dt is equal to du. This becomes my equation 3 and equation 4. Now when I look overall to my integrand, 2 integration of tan 4t into sec square t into dt, I can write this integrand as 2 integration of tan to the power of 4t. This becomes u to the power of 4 because tan t is u. So tan to the power of 4t is u to the power of 4. Sec square t dt is du. So I can write here sec square t dt is my du. Now this is a very simple integration, correct? Because you know the formula. What is the integration of x to the power of n? X to the power of n is nothing but x to the power of n plus 1 upon n plus 1. So u to the power of 4 du would be u to the power of 4 plus 1 upon 4 plus 1, correct? So now we go to the third part, that is 2 integration of u to the power of 4 is nothing but u to the power of 5 over 5 plus the constant term c, correct? This gives me 2u to the power of 5 upon 5 plus c. And what was my u? My u was nothing but tan t. Now I will resubstitute here and I will write resubstitute u is equal to tan t. I get 2 tan to the power of 5t upon 5 plus c. But had I taken t into consideration while starting this integrand, I had taken x into consideration. So definitely I have to resubstitute for t as well. What was my t? My t was root x. So I am going to again here resubstitute t is equal to root x from my equation number 1. So when I resubstitute t is equal to 2x, I get 2 into tan to the power of 5 root x over 5 plus c as my final integration. So overall, if you look at the question very clearly, students, please see the first integration substitution was let root x equals to t. We differentiated it with respect to x, correct? And I get d by dt of root x is equal to d by dt of t. I get the differentiation finally coming to the second equation, dx is equal to 2 into dt. When I substitute these two values, equation 1 and equation 2, in my main equation, I get the integrand in this format. Once I get the integrand in this format, again I do a second resubstitution of tan t equals to u. And why am I doing this second resubstitution? Because you don't know how to integrate ab. There is no way you can do integration of a into b, correct? So you will have to again do the resubstitution, get it in a more simpler format, and we got it. Integration of u to the power of 4, which on integration finally got it to 2u to the power of 5 upon 5 plus c. And then we do the resubstitution. 2 resubstitutions we are doing. Which are those 2 resubstitutions? The first one is for u, that is this portion. U is equal to tan t. This I am resubstituting over here, correct? And the second resubstitution is root x is equal to tan t. This, if you look at, I am resubstituting it over here. And that is giving me the final integration for tan to the power of 4 root x into sec square root x upon root x. Is this clear to all of you? Very clear? Thank you very much.